Hi, welcome back to my channel. Today we're going to be talking about 3.5, proving lines to be parallel. Okay, if you have not subscribed yet, go ahead and do that right now. Go ahead and like the video so you can make my video trend a little bit. Let's get started. So, in our previous video, 3.2, we were trying to prove that if the lines were parallel, then these statements were true. If these lines are parallel, if that was the given statement, let me do a double arrow here so we can tell. Right? If these lines are parallel, then alternate interior angles are congruent. 3 and 6 must be equal. Alternate exterior angles are congruent. 1 and 8 must be equal. Consecutive interior angles are supplementary. Right? That means that 4 plus 6 adds up to 180. Consecutive exterior, 2 and 8 also add up to 180. And then corresponding angles like 1 and 5 are congruent or are equal. So we started with the premise, if the lines are parallel, then all of these things must be true. In this video, it's called proving lines parallel. So we're going backwards. Our goal is to figure out which ones of these properties, of all of the properties that we know, say if these are true, then what lines are parallel? What becomes parallel as a result of the relationships that we know? Now, I purposefully grouped these two together and these two together, these other ones together, because they go hand in hand. Vertical angles. Now, vertical angles here are examples like 1 and 4. They're right across from each other. Does that prove that these two lines are parallel? If 1 and 4 are congruent, does that even affect the second line? The answer is no. So these two being congruent does not prove anything about this other line being parallel, because this second line could be diagonal and these two would remain the same. Same with linear pair. I'm going to change the color for this one. 1 and 2 are linear pair. They're adjacent and together they form a line. They add up to 180. That is a property. Does knowing a linear pair, does knowing that these two add up to 180 affect at all the second line? No. This adding up to 180 has nothing to do with the second line, so it does not prove that these lines are parallel. So these two angle relationships that we just went through do not prove that the lines are parallel. The properties are still true, vertical angles are still congruent, and linear pair still adds up to 180, but it has nothing to do with the lines being parallel or not. These, on the other hand, do. So if alternate interior angles are congruent, we'll do this in green. If alternate interior angles are congruent, like 3 and 6, now notice how 3 does affect this line, and 6 affects this line. Since the angles are touching both lines, and if those angles are the same, now I know that these alternate interior angles are congruent. I know that these lines must then be parallel. Same thing with the rest of our theorems, right? The rest of them also touch both lines. Notice how alternate exterior angles like 1 and 8. Let me go ahead and erase some of this stuff so it can be less confusing. So I'm going to see if I can do them in different colors here. 1 and 8. 1 and 8 affect both lines. And since 1 and 8 are congruent, then it forces these two lines to be parallel. If we look at consecutive interior angles, like these two, 4 and 6. 4 and 6 affects both lines. So if those two angles add up to 180, then by default, I'm going to say equal 180. Then by default, the lines are parallel. Same thing with consecutive exterior. Okay, I'm going to highlight this one. Keep the same color. So like 2 and 8, those are consecutive exterior. Notice how both angles also affect both lines. If those two add up to 180, then it is also parallel lines. And then corresponding as at the very end we have, let's do this in yellow, 3 and 7 are corresponding. 3 and 7 both affect the lines, and if those two are congruent, then the lines are parallel. Okay, so in essence, which properties prove the lines to be parallel? All of them except for vertical angles and linear pair. If these properties are true, then the lines must then be parallel. So very similar to our last video, okay? And we're going to be doing some examples to show what this means. So here I want to prove which lines are parallel based on these given properties. Here I have BCG and FGC. Let's talk about angle. Let's shortcut this a little bit. Let's do this in blue. BCG, I'm going to call this angle 1. So BCG, this is going to be angle 1 right there. FGC, I'm going to call this, let's do this in red. I'll keep it in blue. Angle 2, FGC. So I'm going to start at F, G, C. This is 2. Those two angles, right? If those two add up to 180, which two lines are being affected by those angles? I'm going to highlight this. Notice how those two angles are both touching this line and this line, making the transversal this one right here. So 1 and 2 are consecutive interior angles. So if those two are adding up to 180, then the line KD must be parallel to EG. And I'm going to draw my symbols above it. Since 1 and 2 since 1 touches this line and 2 touches this line, then those two must be parallel. And I ignore the other lines that are there. Let's try the next example. So here we're dealing with angle EFB. I'm going to call this one, let's do it in a different color. I'm going to call this one angle 3 and this one angle 4. So EFB. EFB. I'm going to call it angle 3. FBC, start at F, B, C. This is angle 4. Those two angles are touching these two lines. This line and this line. And since they're right across from each other, then that means that this line is the transversal. Which two lines must be parallel? The ones that the angles are touching. 3 is touching this line, and 4 is touching this line. Therefore, these are alternate interior angles. And since these two are congruent, then line KD must be parallel to EG. So our goal is which two lines are being affected by the angles that we're talking about. Those are the lines that are going to be considered parallel. Let's try 2 more examples. Here we have CFB and GFH. Let's go back to blue. Call this angle 1, this one angle 2. So CBF. Remember, the angle in the middle is the one that we're really interested in. The first and last letter tells us where to start. So we start at C, B, F. This is angle 1. CBF. Angle 2 is GFH. GFH. This is angle 2. Notice how angle 1 and angle 2 are beneath the lines. Beneath this line and this line. If 1 and 2 are being affected by that, then the line that we're interested in as the transversal is this one. 1 and 2 are corresponding angles. And if those are congruent, then line KD and EG are parallel. KD must be parallel to EG. Let's look at our last one. So here we have angle ACD and KBF. Okay, let's do this in red. We're going to call this angle 3 and this angle 4. ACD, so we start at A, C, D. That's angle 3. And KBF. KBF. That's angle 4. Which two lines is it touching? It's touching this line and this line, where the transversal is now across. So since angle 3 and angle 4 are on the opposite sides and on the outside, these are called alternate exterior angles. Now, what two lines are being affected that become parallel? The lines are BH or BF and AJ, if you want to go with that. The vertical lines are the ones that are now parallel. So then BH must be parallel to AJ. So we pay attention to the angles that are affecting both lines. If it's affecting two lines, then the other ones are going to be parallel. If it only affects one line, it doesn't prove parallel. It's got to affect two lines. And here, angle 4 and angle 3 are touching this line and this line. That's pretty much it. Here we have now prove that these lines are parallel, right? I want to show, find the value of x so that L is parallel to M. So I want to make L and M parallel. So what do I know must be true about this angle and this angle? These are corresponding angles. Then that means that these two angles must be equal, must be congruent. So 3x plus 6 must equal 4x minus 6. If those two are equal, that forces these two lines to become parallel. This and this. So I solve the problem so that they do become parallel. Right? Solve x so that it is parallel. And then I just combine like terms and move everything to one side. Right? I'm going to move the x's to the right side. So subtract 3x so that I move it over to the right. I'm left with 6 equals 1x minus 6. I now want to move the minus 6 to the other side by doing the opposite. 12 equals 1x, or x equals 12. In this example, I want to prove that L is parallel to M. The two vertical lines there means that they're parallel, so L is parallel to M. To prove that they're parallel, we call these are consecutive exterior angles. Those two angles have to add up to 180 in order for these two lines to remain parallel. They must add up to 180. So I'm going to do that. I'm going to make this to be true. I have 7x plus 5 plus the other angle, 5x plus 19, has to equal 180 in order for these lines to be parallel. And we solve, right? Since the x's are on the left, I can just combine these. I get 12x. I can combine the numbers because these are like terms. 5 plus 19 is 24 equals 180. Right? Here we're dealing with consecutive exterior angles. So as I'm solving this problem, I'm just isolating the variable. I subtract 24 on both sides. 12x must then equal 156. Right? 180 minus 24. And then I divide both sides by 12. So x must equal 13. And I did this by using the consecutive exterior angles. All right, last example. If I want to prove that these two lines are parallel, what must be true about these two angles? They must be alternate exterior angles. And if those angles are forced to be congruent, then the lines are parallel. These two lines by default will be parallel. Alternate exterior angles are congruent, so I got 7x minus 24 must equal 5x plus 18. Again, move all the variables to one side, isolate the variable, and we got our solution. So I'm going to move the 5x to the left. So I'm going to do the opposite. Since it's a positive 5x, I'm going to subtract 5x on both sides. I'm left with 2x minus 24 equals 18. Now that the x's are on one side, I move the rest to the right side. So we add 24 to both sides. 2x equals 42. To leave x alone, since we're multiplying times 2, the inverse is to divide. Therefore, x must equal 21. So the thing here that we've been talking about, this theme, is what must be true if I want to make the lines parallel? Here we're dealing with alternate exterior angles, right? Before we were doing alternate interior, consecutive exterior, all of these theorems, if they are true, then by default, these lines will be forced to be parallel. So very similar to our last video, except that we're doing the converse of the statement. And our previous videos were told, if the lines are parallel, then what do we know about the angles? Now it's backwards. If I know this is true about the angles, which two lines become parallel? If this video was helpful, click the like button. It lets me know that you've watched it and it helped you. If you haven't subscribed, go ahead and do so right now. And as always, we'll calculate later.